Our brains use rapid electrical and chemical signals to allow us to think and act instantly. Today, we will learn how individual neurons fire signals and form changing connections across the brain. We will first trace the electrical spike, then watch the chemical jump, and finally explore how these connections change. An action potential is the fast electrical message traveling down a neuron's long arm, called the axon. Imagine the axon is a tightly sealed tube filled with a slightly negative electrical charge at rest. Specialized gates called ion channels control the flow of positive sodium and potassium atoms. When a strong signal arrives, the neuron reaches a firing level called the threshold. At the threshold, the sodium channels quickly snap open, allowing positive sodium atoms to flood in. This rapid positive influx causes a momentary reversal of charge, creating the sharp electrical spike we call depolarization. Once this electrical spike reaches the end of the axon, it must jump a tiny separation called the synapse. The electrical charge triggers the release of tiny sacs containing neurotransmitters, the chemical messengers. These chemicals float quickly across the gap and lock into specific receptors on the next neuron. This lock and key mechanism decides if the next neuron is excited and fires its own action potential, or is quieted down. Building on that, the structure of these connections is not permanent. This change is called neural plasticity. Plasticity means your brain can strengthen or weaken the synaptic links as you experience the world. If two specific neurons fire their action potentials together repeatedly, their connection strengthens over time. This strengthening changes the physical structure of the synapse and forms the basis of learning and memory. Let us apply this idea to learning a new language. Initial practice requires struggling across weak chemical synapses to remember new vocabulary words. With consistent practice, these specific neural pathways fire action potentials together repeatedly, forming habits. This repetition physically increases the efficiency of the synapses, making recalling the words easier and faster. Now reflect, how does this physical change explain why skills become almost automatic over time? We saw signals begin as electricity, cross the gap as chemicals, and physically change the pathways of our learning brains. Understanding these complex processes shows how wonderfully adaptable and dynamic your central nervous system truly is. Generate your own educational videos for free at eduvids.vercel.app.